Hello again. So tonight, in this video, I'm going to go over um, these sections right here that will complete this concepts under test 8. Okay, and then I'm going to have another video and I continue with chapter 8 and go into operations with complex numbers using polar forms and also parametric equations. Okay, so I hope you're still doing well, and take care of yourself. Now I'm going to turn off my video and start. So what we want to do is talk about polar coordinates. There are many applications for polar coordinates, and most of them involve rotational movements. And in a rotational movement, when something is rotating in a circle or a circular motion, then the rectangular coordinate is very useful, but the polar coordinates they're much more useful. So, and in many situations, when you write equations in polar form, they're much easier and simpler to work with. Okay, now how does this work? Well, in polar coordinates, basically the points don't go anywhere. We still have the points on a plane. We have the points in a plane. And in rectangular coordinate plane, for example, if we have this point right here, as you see, we have this point right here. Well, the point doesn't go anywhere. It's just that instead of using rectangular coordinate, we're going to use polar coordinate. So if we keep that point over there and draw a number line here and draw a number line here and represent that point with the distance from this line and the distance from that line with two numbers, then we have rectangular coordinate plane, rectangular coordinate system. Now, if we, instead of that, if we take the same point, but consider this point to be the pole, we call it the pole, and then we have a polar axis, which is basically the positive x-axis, and there's nothing else here. So that's it. So I'm going to do it over here instead. So you see, I'm going to have a pole and then polar axis. Now, with respect with the pole and the polar axis, we're going to see how far the point is from the pole, and then how much rotation do we need from the polar axis to get to it. So r is directed distance from the pole, because it could be also negative, and then theta is how much rotation you need from the polar axis to get to that point. It could be positive or negative. So if it's positive, we go counterclockwise. If it's negative, we go clockwise. Okay, so let's practice with this. So here's a point. Where is this point? Well, here is, I didn't want to do that. I want to graph a horizontal line. So here is the pole, and here is the polar axis, right? That's the pole, and that's the polar axis. Okay, now, so there are two ways to do this. One way is to make the angle first, which is the easier way to do it. So we always make the angle first. So we're going to make a 240 degrees angle. So that's 180, right? 240 is about what? Is about right here, right? So that's the angle. Now, I'm not going to draw the the terminal side of the angle with a solid line. I'm going to do it with a dotted line. So that is my terminal side. Now, so that's my 240. Now, from the pole, if R is positive, I'm going to go in the direction of the terminal side this way, and I'm going to go 2 units. So that's 1, that's 2. And I put a point there, right there. So that point is that is the point that this ordered kind of pair of R and theta represent. That's what that point is. So as you see, there are 2 ways to do this. One way is to do the angle first and then do R. Another way to do this is to do the R first and then do the angle. That's a little trickier, so we're not going to do that. And I'm going to show you an example of it. Here you go. So what I'm going to do to make this, I would make the pole and then polar axis, and then do the angle first. 7 pi over 6 is what? 7 times 30, which is 210 degrees. I'm going to go to 210 degrees, which is about right here. And again, this is a dotted line. Now, so that's 7 times 30, 210. Now, since R is negative, I am going to count in the opposite direction of the terminal side, and I'm going to go 4 units that way. That's the point. So you see, this is 7 pi over 6, this angle, and then that's the point. Now, if you make the radius first, which is the distance from the pole first, and is negative, then you have to go in the opposite direction of the polar axis and go over here, right? You go 1, 2, 3, 4 over here. Then 7 pi over 6, you have to start from here and go 7 pi over 6. You count it that way. And that's a little confusing, so I'm not going to have you do that. Instead, I'm just going to do what we always do, the angle first, and then we do the R. If R is positive, we go in the direction of the terminal side. If R is negative, in the opposite direction. So that's the angle. Now that's exactly the same thing we got, right? But what we did was this. We went this way. We made 210 degrees that way, and then we went, this would be the terminal side, we go the other direction, 4, okay? All right, so here's another one. Again, negative 5 pi over 2, where's negative 5 pi over 2? Well, negative 5 pi over 2, you have to go this way. That's 4 pi over 2, and one more, that's 5 pi over 2, that's negative. And then you go, since this is positive, you go in the direction of the terminal side, 117, that way. So suppose this is 117, of course, it doesn't look like it, but that's okay. We assume that is 117. Okay? All right, now what about this one? Well, again, we're going to do it this way. Here's the pole and polar axis. Now, negative pi over 4 is here. So that's terminal side. Now notice that is negative, so we have to go on this side, 1, 2, 3. That's where the point is. That's where the point is. Now if you want to do R first, then you're going to have to go this way first. How many? 3 units. 1, 2, 3. Then you have to measure from the negative polar axis, the opposite of polar axis, negative pi over 4. Negative is that way. Now, again, it's it's a little more confusing if you do it that way. So I'm just going to ask you to learn it the way that I just did, right? All right. So we do angle first and then R. If R is positive in the direction of polar axis, if it's negative in the opposite. All right. Now this tells us that if we have an angle, let's say we have a point, let's say 2 and pi over 6, right? Now 2 and pi over 6 would be, if you go pi over 6 this way, right? So that's my, what did I do? I don't know what I'm doing. Let me get out of this and come back. I don't know what I was doing. All right, so let me go back to it. So we did that. Now, if I want to think of, let's say, do this one more time. Get the pen. Not that, the pen. All right, so if I have 2 and pi over 6, then I'm just going to have to make pi over 6. This is dotted line. And then go 2 this way, right? So that's the point. Now, if I go pi more than pi over 6, I get to this side right here. So this angle is pi plus pi over 6. So if I go that much, then I can get the same point if I change r to negative r, right? So if I graph this point, then I can have a negative r, but get to exactly to the same points, because if I go pi plus pi over 6, which is this much here, then since r is negative, I'm going to have to go to the other side of this I'm going to have to go to the other side of that to do r. So my r would be 2, right? So that means that in general, if I have r theta, then negative r and pi plus theta is exactly the same point, right? If I add pi to theta and change r to negative r, I get exactly the same point. Now, this is also true if I add 2k pi to theta and don't change r. All I have to do is add what? 2k pi, right? Because if this is my pole and polar axis, so if I go theta and then r is a point right there, well, if this is my theta, if I go around and then come to theta and use the same r, I get the same point. So these two are exactly the same point, and these points are exactly the same point, the same points. Now, obviously, I can also add 2k pi to this and get the same, right? So 2k pi doesn't change anything either, right? So I can write it like this plus 2k pi, right? It doesn't change anything, you still get to the same point. But of course, this has to be theta plus pi and then plus 2k pi, and r has to be negative, right? So that's how we can make a point with a negative r, basically. So here is an example. So if I want a point that is the same as that but has a negative r, I can write it as, I make 2 negative, and then the angle, just going to add 180 to it because it's in degrees. So 180 plus that would be 60. So these 2 points are exactly the same. Those 2 points are exactly the same, this one and this one. Okay, now here's another one, 3 pi over 4. So if I can write it as negative 3, well, all I have to do is add pi to 3 pi over 4. And pi is what? 4 pi over 4 plus 3 pi over 4, 7 pi over 4, right? So this point and this point are exactly the same. They represent the same point. So this is something that is different in polar coordinates. In rectangular coordinate system, the ordered pairs are unique. They uniquely represent the points. But in polar coordinates, you can have infinite number of ordered pairs representing the same point. All right? Now, this is the explanation of how to graph this, whether you start with r or start with theta. As I said, you start with theta, so you don't have to go through this. So we start with theta, not with r. So first take care of the angle, and then look at the r and see if it's positive or negative, right? So first you take care of the angle. So if you have you graph your pole and your polar axis, and then you make the angle first, and then if r is positive, you count this way. If r is negative, you go the other way. All right? Okay, so this is the way we do it. If you start with theta, that's how we do it. If you start with r, you have to add, theta to it. So, pi to it, so don't worry about that. Just start with theta when you want to graph polar graphs. Okay, so here are some examples. 5 over 2 pi, 5 pi over 6. So we have to go to 5 pi over 6, right? That's 5 pi over 6. And then since this is positive, that's 2.5. So you go this way about 2.5. That's the point. 7 over 2 and negative 13 pi over 6. Now negative 13 pi over 6 is negative 13 times 30 degrees. That's what it is. It's bigger than 360. So it's going to start from here and go around, right? You go around to get here. So that's what that is. That's negative 13 pi over 6, and 7 over 2 is positive. So in the direction of this, you go how many units? 3.5. Let's say 1, 2, 3.5. Now, next to the r is negative, we still do it the same. We do the same thing, you see. So here is the pole. So I want to graph it this way. I have the alternative method here, so I'm just going to do it this way here. So if you go to angle pi over 2, then since this is negative, we're going to go this way, 1, 2, and 3, something like that. So that would be the point right there, right? So that's how we do it. Now, if you do it with the other method, that would be, you make the r first negative and then go this way, pi over 2, which is a little confusing. So that method is not my preferred method. So negative pi, well, negative pi would be, well, here you go. This is pole and polar axis. Now negative pi means you go this way, right? So this is our terminal site. Now, since this is negative and pi is 3.14, so I have to go to in the opposite direction of the terminal side. See, terminal side is this way, so I have to go the other way. 1, 2, 3, and 3 point something right there. Right? So, oops. There, that's the point. It's going to be there. Okay. So now there is a connection between polar and rectangular coordinate system, and if you put them both in the same place, then this is the pole, which is the origin. Is the polar axis is just x-axis, positive x-axis. And if you have a point here, well, here is x and here is the y coordinate, right? But we know from previous chapters that this point right here is given by x is really r cosine theta and y is r sine theta. So we know from previous sections, and if this is r, we know, and this is theta, then cosine theta is nothing but x over r, right? So cosine theta is x over r, and sine theta is y over r. So if you cross multiply here, you get these two. So x is r sine theta, and y is, so this is x, this is y. Now if you divide y divided by x, you get r sine theta divided by r cosine theta. Now the r goes away. Sine over cosine is tangent. So that means tangent theta is y over x is r cosine theta, y is r sine theta, and we know from previous chapters that r squared is x squared plus y squared. So those formulas relate the polar to rectangular. So the only problem is that when we want to find theta here, we have to take the tan inverse of both sides, and that would be tan inverse of y over x. But remember, tan is only defined in what? Tan is only defined in, tan inverse is defined over here from negative pi over 2 to pi over 2, which is quadrant number 1 and quadrant number 4, right? And quadrant number 4, not 3. So 1 and 3. So in quadrant 1 and 3, 1 and 4, we get the correct answer if you put this in the calculator, right? If you put that in the calculator, you get the correct answer, which is the angle that we want. But if you're over here or over here, calculator is not going to give you the angle that you want. Let's say the calculator doesn't give you this angle. Calculator gives you that one. So what happens is whatever the calculator gives us, we have to add pi to it to get what? To get the angle that we want. If we are in this quadrant. If we are in second quadrant, the same thing happens. You're over here, but the calculator is going to give you this angle, which is going to be a negative angle. So we're going to add pi to it and get to the correct angle. So if the point is in the first or the fourth, this formula works. But if it's over here and over here, then we're going to have to add pi to it for it to work. Okay, so with this, we're going to have the easy way to convert from polar to rectangular and from rectangular to polar. So here are some examples. So now you have to be told that these are what? This is rectangular or polar, because just because they're numbers doesn't mean it's rectangular, because this could be 2 and this could be negative 2 square root of 3 radian. So you have to be told whether what you're given is polar, in polar, or is in rectangular. Now in this case, we are told, it says convert each point in rectangular coordinates given into polar. So these are rectangular, we want to convert them into polar. So the first one is 2, and negative 2 square root of 3 is about right here somewhere. That's the point, right? So what's 2 times the square root of 3 is about 2 point something, so I just put it there, right? Okay, now, so here is the point, so we have to find that distance. Well, that distance is just r square root of what? So r is going to be just the square root of 2 squared, which is 4, plus this is squared, which is 4, and then times 3, which is 12. So that's 16. So r is basically plus and minus 4, right? Now, here it says let r be positive and only find theta in from 0 to 2 pi, right? If we do that, then we don't have to consider the negative 4, and we can actually limit the number of points to a unique one, right? If we do that. So now we are going to find the angle. How do we find the angle? Well, we are in the right quadrant, so all we have to do to find the angle is do tangent inverse of y over x, right? And all we have to do is just go to tangent inverse of y, which is negative 2 square root of 3 divided by 2. There. Now I'm in radian mode, so I'm going to go to degree mode, degrees mode, so I can do the same thing. See, I just pressed enter to do the same thing, but negative 60. So calculator gives me negative 60, which is correct actually. So I can say in polar form, I can write this as 4, right, and negative 60 degrees, right? So that is now negative 60 works, but the only problem with the negative 60 is that first of all we are told to do it in radian. So 4 negative 60 is a good point, but that's not what we want. It does represent this point, but we are told to keep theta positive. Now, if this is negative 60, now in terms of positive angle, what would this be? Well, that would be 300, right? And 300 in radian is 5 pi over 3, right? Because 360 is 6 pi over 3. I mean, 2 pi is 6 pi over 3. Okay, so if you go with what we are given, then we're going to have to write it exactly like we are told. Okay, and the second one? Well, the second one is, again, we have negative 3, x is negative 3, and y is negative 3. So we have a point that is here, right? That's the point. Negative 3 and negative 3. And again, what is x? I mean, what is r? R is going to be square root of 9 plus 9 is 18, right? Square root is simplified, but square root of 18. Now, what is the, well, we have to go tangent inverse of what? Negative 3 over negative 3 is 1. What's tangent inverse of 1? 45 degrees. But notice the calculator gave us what? Gave us this angle. But that's not what we want. We want this angle, right? So what is that angle? Well, we have to add what? Pi to it. And if we add pi to it, then we get the correct answer. So let me erase this. So what is pi plus pi over 4? Well, it's 5 pi over 4. And square root of 18 is 3 square root of 2. All right. What about 0, negative 3? That's easy, because 0, negative 3 is over here. And all we can do is we get the angle, 270 or 3 pi over 2. And then the radius is 3. I mean, the r is 3. So that one is 3 pi over 2 and 3. And then negative 3 and 4, same kind of idea. We can graph it and see where it is. So negative 3 and 4 is over here somewhere. So the distance would be square root of, so r is going to be square root of 9 plus 16 is 25. So that's 5. So r is 5, and so that's 5. Now what's that angle? Well, again, we're going to go to calculator and do what? Do tangent inverse of 4 divided by negative 3, which is not a nice value, but we can write it like that. It's not something we can write in nice form, but that's not the angle that we want, of course. That angle is the angle the calculator gives us. We are going to have to what? We are going to have to add, pi to it. I mean, instead of pi, we have to do, of course, 180, because that's in degree. So the angle that we want is 126.86 degrees. Now, if you multiply it by pi divided by 180, you can convert it to radian, which is 2.21, which is the same thing that we have here, right? Right there. Now, instead of that, you can just write it as what? Pi, right? And then pi plus, this should be a plus, arctangent 4 over 3, because arctangent 4 over 3 itself is negative. That's a typo right there. All right. So that's that one right there, number 4. All right. Now another thing we can do is to take something that is written in rectangular form and write it in polar form. The whole reason that we use, the main reason we use polar form is because polar coordinates is because when you write equations, for example, you can write y equals to x squared plus y squared in rectangular form. And that is basically the equation of a circle centered at 0. But what is the equation of this in polar form? It would be really easy if you write it in polar form. In polar form, if you consider this to be the polar axis and then the origin is the pole, then basically what you have to do is just write r equals to 1, right? If you, instead of y, let's say I have, let's say instead of that, I have 1. Then that would be a circle that is centered at 0, 0 and radius 1, right? So this equation is the same as this whole equation. Now, there are many situations where the polar form is much easier than the rectangular form. And one of those situations, for example, the graph of a spiral, something that goes like this. This written in rectangular form is much harder, much more complicated than written in polar form. And we're going to look at that. Okay, so how do we go about converting rectangular to polar and polar to rectangular? Well, we're going to use the idea that x is r cosine theta, y is r sine theta, r squared is x squared plus y squared, and theta is tangent inverse y over x, or tangent of theta equals to y over x. So this is basically, these are the formulas we use. Okay, so let's look at this. So we are going to write r cosine theta for x, and then for y we write r sine theta, and basically go through this simplifying. That's something minus 3 to a second power. We just raise it to second power. It would be the first one to second power, which is this, and then minus 2 times that, minus 2 times 3 is 6 times that, and then plus 3 squared, which is 9. And then this is just r squared sine squared. Now, the key here is to try to isolate r by itself in order to get the equation for r. And to get r by itself, we can just do what? We can do this, right? Because cosine squared plus sine squared is 1. You can factor r squared out of this one and out of this one and write them together. And then minus 6r cosine theta remains, but this 9 cancels that 9. So all you have to do is just divide by r. So you get r, either r equals to 0 or r equals to 6 cosine theta. And we don't have to consider that because r equal to 0 is already included here. So we can assume that r equals to 6 cosine theta. Why? Because here that has to equal to 0, and if r minus 6 cosine theta equals to 0, then r has to be 6 cosine theta. Right? Alright. That's how we convert. Here's another one, y equals to negative x. Again, we write r sine theta equals to r cosine theta, negative. Right? Here we go. That's it. And did that again, come back. So here we go. And now we move that cosine to the other side, and we factor the r out. So either r equals to 0 or this has to be 0, right? Now, previously we talked about equations, how to solve equations like this. So basically we have to find an angle such that sine of that angle plus cosine of that angle equals to 0. And we know what that angle is. That angle is actually right here, negative pi over 4, because cosine and sine of these two angles are exactly the same except they have opposite sign. So basically this angle right here is the solution for this and any other angle that ends up here. So it's not the only one, that's just one of them. So theta equals to negative pi over 4 is what in polar form it looks like. Now there is no r, that's okay. Remember, in polar form we have r and we have theta. Any combinations of r and theta is a formula in polar form. Just like any combination of x and y is a formula in rectangular form. For example, you can have x equals to 3 or y equals to 4 as equations, In fact, this is a vertical line and this is a horizontal line, right? So in polar is the same thing. If you have, and we're going to look at these in a moment, but you can have theta equals to something. So in this case, theta equals to negative pi over 4 is actually the answer. And from previously, you can actually find all the solutions. What if you had a 3 here, and then you had a 4 here? How do we solve that? We talked about that before. You can refer to the previous discussion and look at that. But we don't need it in this case. We don't want to make it too complicated here. We want to emphasize on polar form. So and this problem is a little tricky because r goes away and you just have to work with theta. So the answer is basically theta equals to negative pi over 4. So that and this both represent the same line. Basically, which line? The line that goes through here, that line. All right, what about y equals to x squared? Same thing. Let x be r cosine theta, let y be r sine theta, and just move things around so you can isolate r by itself, right? So what you get is basically this right here, and if you just divide both sides by r, then we get either r, then we get r cosine squared minus sine equals to 0, and then solve for r here, move the sine to the other side, divide by cosine squared. So basically r equals to this. You can write it, of course, like this too, because if you separate these two fractions, you can write it as secant tangent. But the point is that we have an expression in terms of r and theta instead of x and y. And that's very useful in application problems. Now here we don't need r equal to 0 because it is already included in here. If theta is 0, r is 0, so we don't need it. All right. Now what about r equals to negative 3? Well, r equals to negative 3 means basically if you start with the pole and polar axis, no matter what the angle is, r is always negative 3. So let's see, for example, if theta is 0, then r is negative 3. That means I have to go this way, 1, 2, 3. So this is a point. So if theta equals to 0, that's r. And then if theta equals to, let's say, pi over 3, then r again is 3, right? So 1, 2, 3. If r is pi over 2, if theta is pi over 2, r again is negative 3. That means I have to go this way. If theta is that angle, then I have to go this way, 3, right? So if I connect all of these, you see we get a circle with radius 3, basically. So r equals to negative 3 or r equals to 3, they're both what? A circle with radius r, with radius 3. And that's really simple compared to rectangular coordinate of a circle. That's much, much simpler, right? Now, how do we convert it to rectangular form? Well, we can again consider r squared to be x squared plus y squared, right? And so we can square both sides. We get r squared equals to 9. And then we know what r squared is, x squared plus y squared. So x squared plus y squared equals to 9. That's the equation. Now, does r squared equals to 9 represent the same points as r equals to negative 3? Yes. In polar coordinates, these two are actually the same, right? We talked about that. All right. So what about theta equals to 4 pi over 3? Well, we don't have anything to directly use to do that, but we can take tangent of both sides, right? If we take tangent of both sides, then we know that the tangent of theta is going to equal to tangent of 4 pi over 3. But we know tangent of 4 pi over 3 is the square root of 3. So this is the equation, really, is equivalent to that. But we know what tangent is y over x. So here we go. And then cross multiply, you have the equation. So this line, which is really 4 pi over 3 is like 240 degrees, right? So this is the line really. When theta is 4 pi over 3, r is free. So r is free. R can be any number. So if theta is fixed to be 4 pi over 3 and r is free, then you can make any other angle except for this one, and you're stuck right here. You just have to go to different r's, and r is free to move, so you go to different r's here, whatever. And if you do that, you get different points, and then if you connect them, you get a line. So the graph of theta equals to 4 pi over 3 is just a line. Which line? Basically is a line with the slope of square root of 3. Y equals to, sorry, my drawing is off. Sorry about that. So theta equals to 4, so tangent of theta here equals to square root of 3. So we got y equals to square root of 3 times x. So it's going to be a line, square root of 3, so it's going to be like this, like that. Now this 240 degrees, sorry, my fault. So that's the graph. That's the angle. I had the wrong angle. 4 times 60 is 240. I have an angle over here. It should be over there. Okay, we fixed it. So those two lines are basically the same thing. Okay. So this line right here is y equals to square root of 3x, which is the same as when theta is just 4 pi over 3 and r could be any value, right? All right. Well, I know why, because I thought that was pi over 6. I did 4 times pi over 6. It's 4 times pi over 3. All right. So let's move on. And what about r equals to 1 minus cosine theta? Well, again, this one directly we don't have anything to work with, but we can multiply both sides by r. So it would be r squared equals to r times 1 minus cosine theta. And that we can write it as what? We can write it as, here we go. And that's something we can work with. So r squared equals to r minus r cosine theta. And now if you factor r out of there, right, then what do we get? Well, again, we have another r here that we don't know what to put for. This is good, this is x, this is good, this is x squared plus y squared. But what do we do with that? So what we have to do is we have to square, we have to isolate this r by itself and square both sides. So we're going to move this r, move this right here to the left side, have this by itself, and then square it. So we have r equals to r squared plus r cosine theta. And now I'm going to square both sides and square this side, right? Now we can write everything in terms of x and y because we know what this is, x squared plus y squared. We know what this is, x squared plus y squared. we know what this is x, and then to the second power. We just leave it like that. Now, as you see, the expression in polar form looks much, much, much simpler than this thing right here, right? It's much more complicated in rectangular form. All right. Now, so let's look at some families of polar graphs. We are going to now categorize them and look at what they look like. So r equals to 4 is just r equals to a constant. Is just a circle. It's a circle with radius 4. That's what that is. So r equals to a constant is just r equals to is a circle with radius, that number, whatever that number is. Because you see, theta is free to be any value. So you could go here, this is your theta, or theta could be here, right? Or theta could be, whatever, doesn't matter. But your r, no matter where you are, where your terminal site is, your r is always 4. So you always have to count 4 to get to here. Always have to count 4 to get to here, and so forth. So no matter what angle you make, r is always 4. So you basically get a bunch of points on a circle. And the same thing is true here. Even if r is negative, you still get a circle. So it doesn't matter. R equals to negative 3 square root of 2 or 3 square root of 2 represent the same circle. What about if theta is fixed and r could be free? Well, if theta is fixed and r could be free, then you're stuck with one theta. Let's say you're stuck over here, 5, not here, but over here. 5 pi over 4, which is 5 times 45 degrees. And let me erase this. Okay. So we have 5 pi over 3, and then r now could be any number. So you go anywhere here. As long as you're here, you can be negative or positive. So if you do that, you get a bunch of points that are on what? They're on this, on that line, right? So that's what you're going to get. All right. So here's another one again. Theta equals to negative pi over 2. You just get the vertical line, y-axis, right? Negative pi over negative 3 pi over 2 is like this way, right? And then r could be any number, so you go up and down here to get to any point on this line. So graphs of constant r and theta, as we discussed, if theta is constant, we get a line. If r is constant, we get a circle, right? So basically but these are circles that are centered at 0, 0, right? The center is the origin. All right, so that's easy to graph. So let's look at another type of polar graph. What does this look like? Well, this one is going to look like what? Well, in order to do this, we have to graph this. Now, to graph it, we can have a bunch of values for theta and a bunch of values for r and graph it. But it's easier to think of r equals to 6 cosine theta in rectangular coordinate planes such that, such that this is theta and this is r. So, and then get a bunch of points on this, bunch of points that you're familiar with from previous chapter. So familiar with those points, right? Then you can take those points and then graph them in what? In polar axis, like that. So get this point 0 when theta is 0. This is, let's say, 6. So you go to here and you go, okay, that's my first point right there, right? And so forth. And then you get a bunch of them and you connect them, you get the polar graph. So let's look at that. So you see that? So if you take all of these points and graph them, that's that one right there. This next point is going to be that one. This next point is going to give you that one, and so forth. That next point gives you that one, and so forth. So, and if you do that, go through one complete cycle of theta here, 0 to 2 pi, you end up with what? You end up with the complete graph of 6 cosine theta in polar. So now if you continue and take some of these points there, you end up with, now notice over here, r is negative. So for example, if you go to this point right there, right, that angle, which is past pi over 2, which is, right, let's say is over here, right? So if you go to that angle, right, then r is a negative answer. So you're going to go this way and put a point there, right? And if you go to this number right here, again, this is an angle. Let's say you go further this way, that angle, then r is negative. So you have to go that way. You get that point, and so forth. So all of these points and all of these points, they convert to those points that you see there. And then we continue. And if you continue and graph the rest of this part and that part, then you're going to get a complete graph of that circle. Now, here's something that that could be tricky, depending on the shape and the structure of the polar equation. The period of this in the xy coordinate over here may not be the same as the period of the polar graph that goes around here, right? And that is something that we don't emphasize here in this course, but is actually not that simple. The connection between them is not a straightforward connection. You have to make many cases. So we don't want to spend too much time on polar graph in this course and go through all that. It goes beyond what we want to do in this course. So what I suggest is you learn how to recognize these polar graphs and make sure you know how to do simple ones with understand how we get the points, how we get the points from here to there, right? And then use technology, calculator and computers to graph polar graphs. That's how much we want to cover. When you get to calculus, you can work on it a little bit more, but that's how much we want to do in this course. Okay, so let's take a look at another one. So here is another one, and as you see, if you start with this graph in rectangular coordinate plane, assuming that horizontal is theta and the vertical is r, then you can take each point and convert it to, for example, at this point when theta is 0, r is what? R starts from 4. So when theta is 0, r is 4. So that's the point right there. And then if you continue this way and get a bunch of points, you see the shape of this thing creating. And that's what it's going to look like. First it's going to look like that. Then it's going to look like that when you continue this part. And then for this part, it's going to look like this. And then for the rest of this, is going to be completed. And in this case, you see that 2 pi, one period of sine completes one rotation of this. So if you continue, you just go over the same graph over and over. So, all right. So now, so that's how it is graphed. You have to have a bunch of points, and it requires a little practice. But as I said, just we emphasize more using technology for now for polar graphs. Now here is something we can look at. If I can get to here and turn off my pen, we can look at this graph, and you see the connection between the points on the rectangular one and the points on the polar one. So let me show you here as to, all right here. So you see, here is the equation, negative 1.65 plus 1.15 cosine theta. So I'm going to go from, this is in radian, right? So let me clear that. So you see, as I go to the right here, I'm basically moving over what? Over this rectangular coordinate plane. We assume this is rectangular coordinate plane, and this is the graph of that. If we assume this is t and this is r. See, I'm going over it. At the same time, look at the blue one. The blue one is actually the one that is graphing the points in what? In polar. So notice that how the polar one is graphed. As I move to the, my computer is a little getting slow, too many calculations. So you see that? Where am I? I'm about, you see, you can tell what angle I'm at, right? 4.25 radian. And then when I get to what number? This is complete. 6.28, right? That's 2 pi, about right there. Something like that, right there. You see? So 2 pi radian on this graph will give you one complete cycle over this. See, what we are doing with the blue graph here is that as r goes up and down here, r goes back and forth like that. So we're turning it, like, think about wrapping this graph around this circle. That's what it's going to look like. If you wrap this graph around the circle, that's what it looks like. And later, in calculus, engineering calculus, you learn about Fourier series and transformations. You're going to learn how we can convert a graph like this to a rotation like this. And that comes later. But for now, you just have to understand this connection between rectangular and polar, okay? And this is in the notes. You can play with it. If you download it in your computer, you can actually change this and then change the equation here. But that's what this is, okay? I can change this to something else, you see? You can change that to something else, but I just wanted to show you the connection here. So let me move on. All right, so let's look at some families of polar graphs. Families of polar graphs, circles not centered at 0, 0. Remember, centered at 0, 0 would be just r equals to a by itself. That would be a circle at 0, 0. But if we have a cosine theta or a sine theta, then we get a circle. And a cosine theta is on the x-axis, and then a sine theta is on the y-axis. Now, if this is positive, then you're on the positive x-axis. The circle is on the positive x-axis. And the diameter of it is the same as this number right there. And the center is like in the middle of this number. So the center is at 3, 0. If this was 4, this would be 2, 0. And then the circle sits right there, touching the y-axis, but centered at 3, 0. And if it's 2, this is 2 actually, this one is this one, because this cosine. So sine 1 is on the y-axis, so the diameter is 6, and the center is half of that. So the one I was pointing at is this one because this cosine is on the x-axis. So if this is negative 2 cosine, then it would be over here. If this is negative 6 sine, it would be over here. All right, so these are called circles. Now, if you modify it, just instead of 1 theta, if you put more than 1 theta, like 2, the n is an integer. We assume in this case is an integer. If you change it to something else, still works, but you don't get these. You get something else. So n here is an integer. So if n is an even number, these are all called rose curves, because they look like roses. So if this is even, then you end up with as many petals as 2 times this number. So if it's a 2, you get a 4-petal shape. If it's an odd number, then you get exactly that many petals. So for example, this 3 one would have 3 of them. And if it's 4, it would have 8, right? If it's, again, it could be cosine or sine. The difference is where they start, where the petals start. So if it's a cosine, then it starts on the x-axis. Why? Because when this is 0, cosine is 1, and 1 times 4 is 4, see? So r at 0 is 4, and so forth. So these are called rose curves, and they're very easy to recognize. These right here, notice that here we have a cosine n theta and a sine n theta. Before we just had a cosine theta, a sine theta. Now, if you take this and add a constant to it, then we're going to get something called cardioids. Now, they're cardioids if these two numbers are the same. I mean, in terms of absolute value. If they have the same value, then you get a heart shape. That's why it's called cardioids, because it looks like a heart. And depending on what we have here, if the coefficient of cosine is negative, it would be on the negative x-axis here. And then if it's positive, it would be on the positive x-axis. If it's sine positive, it would be over here. And if it's sine negative, it would be over here. Just like the circles we discussed. Except these numbers would change the shape to a cardioid if they're the same. Now, if they're not the same, then we get something called limison. Limison. So limisons are basically cardioids, but they don't look like heart anymore. They look like what? 3 different shapes. So depending on whether A is bigger or B is bigger, they can't be the same, because if they're the same, then you get the heart shape. Depending on which one of these is bigger, you either get something that is not a heart. See, there is a space here, so it's not a complete heart. This doesn't go all the way to this point and come back. Or it actually has an inner loop here. Or it would be really off. Over here almost looks like a circle. So depending on what these two numbers are in terms of value. And these are called limison, right? So again, we have cardioid and limison. They look basically very similar, except these two numbers for cardioids are the same in terms of value, but they're different here. All right, so here is another example. It's called the Archimedean spiral, and the equation of it is given by r equals to a plus b theta. Now, the equation of this in rectangular form, it would be much more complicated. But here, as you see, is not that complicated. It's just a number plus a number times an angle. And what happens here, as theta increases, r increases in a way that makes a spiral, kind of goes like that. And here's an example of a spiral. And these two numbers determine how compact these circles are. They're not circles, but circular paths are. So this is called Archimedean spiral. If you get r equals to theta or a plus b theta. R equals to theta itself is an Archimedean spiral. And then one more family, and these are called lemniscate. Lemniscate is basically a shape that you get when you multiply the distances from 2 points, 2 fixed points, and those products are the same. So you know the definition of a circle in geometry is basically the set of points in the plane that are the same distance from a fixed point called the center. And then we have ellipses. We're going to get to these later, but for now, this is similar to those. But the definition is instead of sum of the distances, or if instead of distances be the same, here, if you multiply the distances from 2 foci, 2 fixed points, you get a constant number, constant value. And that's the shape that you get. Again, in rectangular, it would be much more complicated, right? But in polar, is much easier. So either r squared equals to sine 2 theta, or r squared equals to some number times cosine. So r squared equals to a squared sine 2 theta, r squared equals to a squared cosine 2 theta. And now this, the right-hand side has to be positive because this is r squared. R squared cannot be negative. So that puts a limitation on what theta can be. Because if you want sine to be positive, sine is positive where? Sine is positive over here, from 0 to pi. So if you want this to be positive, then 2 theta has to be between 0 and pi. So that means 2 theta has to be, let me get the pen. So 2 theta has to be between 0 and pi for theta to be positive, 2 theta. So theta has to be between 0 and pi over 2, right? Because you have to divide by 2. So that's what's going to be. So this is the limitation on the domain because we want the right-hand side to be positive. But when you graph them, you get this. So for sine 2 theta, r squared equals to sine 2 theta, a squared sine 2 theta, and a squared cosine 2 theta. These are called lemniscate. All right, so now the last thing I want to do, I want to represent complex numbers using these polar coordinates. Now, you know, complex numbers are given by, a plus bi, or just x plus yi, right? Now, to represent this in terms of, in polar form, we can think of x here as r cosine theta, and think of y as r sine theta, right? So what do we get? Well, we're going to represent a complex number with something called a letter z. So z is x plus yi. So x is r cosine theta, y is r sine theta, and then times I. So bring this I here before r, and then take the r out, factor it. Then we get z equals to r cosine theta plus I sine theta. That's the polar form of a complex number. So a complex number can be written in terms of polar form. It's very similar to converting rectangular to polar, except for this I here, right? Now, this has a compact notation, and it's called cis theta. So r cis means that. That means to expand this into what? Into cosine theta plus I sine theta. You see, cis is cosine theta plus I sine theta. That's why it's called cis theta. So R is called the modulus or the magnitude. It's called the modulus, and theta is called the argument. So you know, to find the R is very easy. It's basically square root of R squared, x squared plus y squared, right? So it's very easy to find if we want to find, if you have a complex number, let's say z, when we put absolute value of z, we mean that. We mean that distance. And that distance is always the square root of x squared plus y squared. Okay? So that's how we convert a complex number to its polar form. And now let's do some problems from Newton alpha. We talked about all this. So we are going to, so here's an example. Let's do an example and then we go through Newton alpha. So it says, on the complex plane, the number z equals to 4i is the same as z equals to what? 0 plus 4i, right? So writing it in polar form, we have to calculate r first. What is r? R is the square root of x squared plus y squared. So it would be 4, right? And x is 0. That means r cosine theta is going to be 4 cosine theta. And if you set it equal to 0, theta is going to be pi over 2, right? Because x is 0, right? And that's r cosine theta, and we know r is 4, so theta has to be pi over 2. And then, so z is going to equal to that. Now, of course, we know how to find theta. Theta is what? Tangent inverse of y over x, right? The same idea applies if it's over here and over here, you get the correct answer with the calculator. If it's over here, you have to add pi. And so let's do some examples from Newton alpha, okay? Let me get out of here and then go to Newton alpha. And it says convert between rectangular and polar form. So let's do that. It's too few. I'm sure you can do it. So given the point 7 pi over 2 in polar coordinate, find the Cartesian coordinates of the point. So I'm going to show you the work quickly. So we know that, so we have 7 pi over 2. So this is, let me grab this so I can write on it. There we go. Computer is becoming slow. All right, so it's 0. What was that? 7 pi over 2. So 7 pi over 2. So that means you have to make an angle pi over 2 and go 7 unit. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. I shouldn't have put marks in it. All right, so that's the point, right? So that's the point. Now, what are the polar of that? Well, it's very easy. You can even tell just by looking at it, right? Rectangular form of it. But let's do it using formulas, right? So we know x is r cosine theta. So we're going to just multiply 7, right? Cosine pi over 2. Now what's cosine pi over 2? 0. 7 times cosine pi over 2 is 0. And what is y? R sine pi over 2. So what is pi over 2? R sine pi over 2. Well, sine of pi over 2 is 1 times 7 is 7. So y is going to equal to 7, right? And x is going to equal to 0, right? And that's all. So converting these points is not really hard if you write the formulas down, right? So find the polar coordinates of a point with Cartesian coordinates x, y equals to that, right? Again, just use a calculator. You know that. Well, let's do it together. And then since this one is rectangular, so we have x and we have y. So now what we have to do to find the polar, first of all, we have to find r, right? And r is, let me grab this. So first of all, we have to find r, and r is the square root of x squared plus y squared. Now x is negative 5 over 2, and y is that. So we just do the arithmetic here, we get 5. So that's my r. I know my r is 5, right? Now I need to find theta. Now remember, theta is what? Tangent theta is y over x, right? So my y is that, and my x is that. You just have to divide them. Right here you see. And if you divide it, that would be 5 square root of 3 over 2 times what? Well, reciprocal of that, which is negative 2 over 5. The 5 goes away, 2 goes away, so that's just negative square root of 3. So that theta is going to be tangent inverse of square root of 3. But remember, where is the point? The point is in which quadrant? X is negative and y is positive, so the point is over here, right? Now, if you put this in the calculator, put tangent inverse of negative square root of 3, calculator will give you this angle, which is negative pi over 3. So now you have to add pi to it to get the correct angle. So it's 5, and what's the angle that goes with that? Pi plus negative pi over 3, which is 2 pi over 3. So that has to be 2 pi over 3, which is this plus pi, right? All right. So which one of the points below correctly plots the point 2, 7 pi over 6? Well, you can easily tell, right? 7 pi over 6 is 7 times 30 is 210 degrees. And this is 30, so each of these little one is 15 degrees, and these are 30 degrees, right? So this is 7, 210, so that's 180, that's 210, and then r has to be 2, positive 1, 2, right? So it looks like the answer is C, right? All right. So that's how you do this section. What is the other one? Well, conversion between rectangular and polar form equations. And I did few of these for you. These should be very similar. So here is one converted to Cartesian coordinate, okay? All right, so to do that, remember the formulas that we have are r squared is x squared plus y squared. That's r squared. And then we know x is r cosine theta and y is r sine theta. And theta is tangent inverse of y over x. But well, we can't do anything here because they don't look like what we have here. So what do? Well, we can multiply both sides by r. If you do that, then we get r squared equals to 4r sine theta plus 6r cosine theta. This is x, this is y, and this is x squared plus y squared. And that's it. So it's really is not that hard to get this. So x squared plus y squared is equals to 6x plus 4x. So these are, I think I did a bunch of them already for you. They're not that hard. So introduction to polar graphs. I did a bunch of polar graphs for you, but let me do one more. Now this one says which one of these is the correct graph. So in order to do that, we need to look at this. So I'm just going to put it over here so we can look at it when I go down. Is this the graph of these points? Well, let's see. Where is 0 at 0? We are supposed to be at 0, right? So it looks like at 0, theta, we have to be at 0. So it looks like it's correct. At 0, you've got a point way over there. It's not at 0. What about this one? Well, we got a point right there. Well, it could be there is a point at 0 as well, but we don't know which one it is. So let's look at another point. Pi over 6 has to be negative 0.66. At pi over 6, we have to be at negative 0.66. So if you consider that to be pi over 6, which is 30 degrees, then we have to go to the other way, because if this is the angle, r is negative, we have to go the other direction. So it's going to be over here somewhere. So that can be the answer. What about this one? Again, we check and see if we can get, see these are all negative values, right? So at pi over 6, we had negative 0.66. This could be answered because this is pi over 6, and then you see this is less than 1. And then at pi over 3, which is 60 degrees, let's say this is 30, it's about 60 right there, that angle right there, then looks like it's a little bit more than 1 negative, which means could be that one. Pi over 2 should be 2.5 negative. So we are at pi over 2. I have to go this way, 2 point something negative, it looks like that one. And then 2 pi over 3, which is 120 degrees, 90, 120 right there. It looks like we are in the right place. So it's, I would say, for now, that could be the answer, and it is, yeah. That second one is the answer. So if you grab that and check, and you can easily find which one is the graph of those points, right? All right. This is the same, so I'm not going to waste your time and do similar ones. Okay, now write complex numbers in graph or polar. I'll let you do that one. As I said, use technology to do it. I don't want to emphasize it. So I'm going to do one of these complex numbers to polar forms as well, I mean, for you. So it says compute absolute value of 5 minus 2i, give your answer a simplified radical. Now, remember the formulas that we talked about. We said that absolute value of complex number is basically r, which is the square root of x squared plus y squared. Now in this case, x and y are a and b. So that's all there is to it. Let's do another one. Express the complex number in polar form r cis theta. Now, again, where is this thing? Let me get rid of that and make another one. So again, cis means what? R cosine theta plus I sine theta. That's what it means, okay? Now, all we have to do is find R, which is very easy because z equals to 6 basically is 1, 2, 3, 4, 5, 6 right here. That's what that is, right? 1, 2, 3, 4. So that's what it is. Now, over there, how do we represent that using that? Well, that's easy. All we need is r, which we have, is 6, right? And then the angle, what should the angle be? Well, the angle is 0 here. So really, all we have to do is write 6, and then inside here we write cosine 0 plus I sine 0, right? And that's it. And that is cis 0. That's what that is. So 6 cis 0 is actually the same complex number. All right, these are not very difficult. You just have to practice. So we are done with all the stuff that this test covers. And then next video I'm going to continue and create more, talk about more sections, okay? So I'm going to take care of yourself, and I see you in the next video. If you have any questions, email me, or you can make an appointment, and we can have Blackboard collaborative, and I can be there and answer your questions face to face virtually. Okay. All right. Take care of yourself. I see you in the next video.